Okay, sorry this is getting out so late, kiddies. I actually was out tonight and I just got the test anyway. Had to make an answer key up for it. Myself and my partner, Miss Newman, made an answer key, so we should be all set. By the way, the other three of these videos can be found at, where am I going to put these? www.Mr. Krause Math. I'm not going to put them up here. Probably won't put them up there. This is the last Regents. Hopefully you're getting these copies. Hopefully you subscribe to my YouTube channel so you're getting these. And cheers, because I'm going to need the coffee to stay awake, because it's like 9 o'clock and it's like past my bedtime. So my name is Mr. Key, otherwise known as Mrs. Krause, Mr. Krause. My partner in crime is Miss Newman, and we're at nkinfinity.com. By the way, if you haven't taken the time to subscribe, please do so. Infinity.com. This is part 1. Part 1, 1 through 14. How did you do? Did you study hard? Was it an easy test? Quite honestly, we'll see. As I go through, I'll talk about when I can use my calculator and when I can't. But since this is the last of these Regencies, you can expect that I'm going to be going through this rather quickly. This is not going to be a teaching video. It is going to be strictly an informational video. Okay? I apologize about the way that, I don't know, my scanner didn't scan it very nicely. So I apologize the way it scanned. You'll have to just deal with that. Hold on, I'm trying to get my setup. Okay, here we go. Problem number 1. Problem number 1. Number 1. Here we go. Let's see. The roots of the quadratic ax squared plus bx plus c are real. Real means it's greater than 0. The discriminant is greater than 0. Irrational and unequal. Now, because it's real, it's got to be greater than 0. Because it's unequal, it can't be. Well, actually, because it's real, it's got to be greater than or equal to 0. Because it's unequal, it can't equal 0. So, we know it can't be equal to 0. We know it can't be less than 0. And then this is the most important word. Irrational means you are not able to take the square root of it nicely. It's not a perfect square. So the answer is it is a number greater than 0 and not a perfect square. Anybody 1 for 1? I hope so. That wasn't a bad problem. Factored completely. Factored completely. This is one of those ones that, if you don't pay attention, you could get wrong. So the first thing you got to do, as always, is take out the GCF. And the GCF in this case is tangent theta. When I take out a tangent theta from this and from this, I'm left with 16 minus tangent squared theta. Well, I hope you did not stop there. Well, actually, they didn't even leave that as an opportunity, but hopefully you didn't stop there. Sorry. You need to understand that this is the difference of two squares or the difference of perfect squares. So we can factor that to, let's see, 16 is 4 times 4. Tangent is tangent theta times tangent theta, and hopefully my big head's not in the way here. And then 1's plus and 1's minus. So we will be looking at choice 3. Let me make sure. 4, 3. Did I get this right so far? So far I'm good. All right. Choice 3. Hilton High School officials wanted to assess the need for a new diving board. They created a survey and distributed it to a large, diverse crowd at the state swim meet held at their school. Which characteristics of the survey is most likely to create bias? The number of participants. No, you want a large number, that's fine. The height of the participants. Huh? What? That's a dumb answer. The way the set of data from the survey was analyzed. They didn't even discuss how it was analyzed. And the way the participants were selected. You ask about a diving board to swimmers. That doesn't make any sense, okay? And because you're only asking swimmers and you're asking a crowd at a swim meet, yeah, we need a new diving board. Yeah, we need a new diving board. But do you really? So, because you only asked swimmers, it was considered bias. All right. Which expression is equivalent to cosine P cosine 50 minus sine P sine 50. Oh, shoot. Hold on. Where am I in? I do have the formula sheet. So what you have here is cosine cosine minus sine sine. So you need to go over to your formula sheet and say, okay, which one of you is cosine cosine sine sine? Cosine cosine sine sine is the law of cosine. So it's either this one or it's this one. Now, if I remember correctly, it had a minus sign in between. Let's take a look. Sorry, every time I come back, I got to find my way back. See how it's got a minus sign in between? So it's cosine cosine minus sine sine. Well, that comes from the formula cosine A cosine B minus sine A sine B. So that's this thing right here. Cosine of A plus B. Oops. So when I go back to here, and of course do this, and of course have to do this, I'm looking for the one that says cosine plus. And there it is right there. Ka-ching. Anybody 4 for 4? So far, it's not a bad test, guys. So far, actually pretty easy. So far, we'll see. Keep going. Let's keep going. We'll keep swimming. We'll keep swimming. I love Dory. She's awesome. I'm just kidding. Sort of an annoying person. All right, what is the product of the roots of this quadratic? So the first thing you got to do, I'm tired of that color, is to set this equal to 0. So you get 2x squared minus x minus 4 equals 0. Now the product of the roots can be done one of two ways. You can just simply use the formula product is equal to C over A. So in this case, negative 4 over 2, which is just negative 2, and choose choice 3. You could have come over here and done, go into your calculator mode, go menu 3, 3, 1, and type those in. 2, negative 1, negative 4. 2, negative 1, negative 4. Enter, enter, enter. Oh, that's not good. So that I'd have to find the product of those roots, and that's kind of ugly. But the answer is negative 2, number 5. Let me make sure. 1. I should put numbers on here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Sorry. Got my answer key over here. Choice 5 is choice 3. Perfect. We're doing good. I'm 5 for 5. Are you 5 for 5? In which method of data collection does the researcher intentionally intervene to arrange for a comparison of results? So, when you take a survey, are you intervening? No. People are just answering questions. When you make observations, are you intervening? Intervening means you put yourself into the situation. Nope. When you have people fill out a questionnaire, are you intervening? No. When you conduct a controlled experiment, absolutely. Because what you're doing is one group gets the medicine and one group doesn't. So you're putting yourself in the middle of that observation. So that's choice 4. Moving on. Anybody 6 for 6? So far, so good. Which equation could be represented by the graph below? Now, since it starts at a maximum, it's got to be a cosine curve. So I'm going to guess right now it's probably one of these. Since it starts at 2, that means the amplitude is equal to 2, probably, which would make it this one. It also would take let's see. Oh, the other thing is it finishes only half of a curve in 2 pi. You understand? So in order to finish this thing, right here, this would be, I don't know, only finish half a curve in 2 pi. So this would be, that's pi. This would probably be 2 pi. So there's 2 pi, and then there's 3 pi, and then there's 4 pi. So I only finished half of a curve in 2 pi, which is also why it is choice 2. Anybody 7 for 7? All right, I got to take a break. I'll be right back. Did you see how my mouth and my voice and what you heard was a little off on that last one? That's because I waited too long. Sorry about that, children. I'll try not to do that. The first four terms of a sequence with a sub 1, what number are we on? 8? That's 5, 6, 7, 8. Okay. The first four terms of a sequence, A1 is 40, A2 is 3/4. So this is a recursive sequence. So we'll start with A sub 1 equals 40. So the first four terms are this would be stupid and this would be stupid. So it's got to be one of these two. So it's got to be 40 to start. Now A sub 2 would be equal to 40, times, the way it's written is 3/4 times 40. Well, 3/4 times 40 would be 30. So the second term would be 30. 30. That's what I expect. A sub 3 then would be 3/4 of 30. So that I need my calculator for. Go over here and I say, okay, control division 3 over 4 times 30. Enter. I knew it was going to do that too. I should have put a decimal in. Decimal. Enter. 22.5. So that's equal to 22.5. Anybody got that? There it is. 22.5. Boom. And I can check that one more time. By the way, this is the easiest way to do this. You just, the easiest way to do this is to just put 40 in. And then you do 3 decimal point, control division, 3 decimal point, because it needs that, over 4, times control answer. 30, 22.5, 16.875. Boom, there it is. And choice 2. Great, perfect. What was that last one? People are bugging me. People want the answers. Stop bugging me. All you people texting me. Miss Bedford, I just got your text. Or your email. I'm coming, leave me alone. All right, moving on, here we go. Only going to do 12 up through 14 on this one, so we got about, 5 more? Which diagram represents an angle of 7 over 4 pi radians? Okay, if you remember correctly, 2 pi is all the way around a circle. So 2 pi would be the same as 8 over 4 pi. Well, this is a little less than 8 over 4. So how much less? Well, it's 1/4 of a circle. So I've got to cut this thing into fours. 1, 2, 3, 4s. Okay, and I need to get around 7 of them. 1, 2, 3, 4, 5, 6, 7. I need the one that's going to end right there. And that would be choice 1. Uh-oh, got a discrepancy of answers here. Which represents an angle of 7 over 4 pi radians in standard position? Hold on, I got a discrepancy. My answer, I have 4 written down, but I don't think that's the right answer. Hold on. Standard position would be, oh my gosh, hold on. So the answer to choice 9 would be 1. I don't know why I put 4. The answer is 1. 7 pi over 4. This would be 2 pi, and we're not quite there, so you got to come back just a wee bit, and there it is. Choice 1. So I'll have to fix that one on my own answer key. This is why I do it twice, so sometimes I make a mistake, sometimes I don't. I don't know. For all values for which of the function is defined, for all values for which of the following functions is defined, blah, is equivalent to blah. Okay. So another way to write this would be the square root of A over the square root of BC. And then we can rationalize it by multiplying by the square root of BC over the square root of BC. Well, what in the numerator, since they're both under radicals, I can just multiply these together and I get the square root of ABC. And the square root of BC times the square root of BC is just BC. So I'm looking for this one. Looks like it's choice 4. Ka-ching! All right, moving on. Number 11. Well, first of all, let's do this. Let's take care of this situation. When you have an exponent raised to an exponent, you just multiply these exponents. So that's what we're going to do first. So x, 1/2 times negative, what's half of negative 6? Oh, that's negative 3. Times y, what's negative 2/3 times negative 6? That's positive 12 over 4, or excuse me, over 3, 12 over 3, which is 4. Now you have to remember that negative exponents, in order to make them positive, they must go in the denominator. So this really turns into y to the 4th over x cubed. This one easily could have been done with a calculator. Plug in a number for x, plug in a number for y, type the whole thing in, and verify that choice 1 is, in fact, your answer. All right, I'm going to take a quick break. Hopefully my voice is... Okay, here we go. Let's work on this one. This is another one, I believe, that can be done using your calculator. 10, 11, 12. Let's see. Where I is imaginary. Let's see. So this is the sum. So all I'm going to do then is add, I plug in a 4, so I to the 4th, plus I to the 5th, plus I to the 6th, plus I to the 7th, plus I to the 8th. So I'm going to plug in I to the 4th, I to the 5th, I to the 6th, I to the 7th, I to the 8th. So these two are 1. So I to the 4th is 1. I to the 5th is really 1 times I, right? You guys remember your I circle? I to the 1 is just I. I squared is negative 1. I cubed is negative I. And I to the 4th is, that's a 4, by the way, every time you know my 4s. I to the 4th is equal to 1. So I to the 4th is equal to 1. I to the 8th is equal to 1. Now, I to the 5th is just I. I to the 6th is negative 1. I to the 7th is negative I. And I to the 8th is 1. So I come through and I say, okay, 1, negative 1, I, negative I, ka-ching. Now, again, I could have just typed that in your calculator. Bam, it would have spit out 1 in no time. 1. Which expression has the value of the square root of 3 over 3? This is a tangent. So more than likely, it's the tangent of 60. Let's think about that. I don't know. Maybe not. I don't think so. I don't think so. So if you want, I believe this is the answer. I'm 100% sure this is the answer. But how do I check that? How do I use my calculator to check that? I come over here and I say, okay, I want the cotangent. Shoot. The cotangent of 60. Okay, well, is that right? The square root of 3 divided by 3. Oh, yeah, there it is. Done. Calculator. And finally, oh my goodness. More than likely, this is the answer. I don't remember now, but I'm going to check to see, make sure that's the answer. By the way, we're going to divide by negative, just to do this the right way, just for fun. You're going to get the absolute value of 2x minus 9 is equal to positive 11. So you get 2x minus 9 equals 11. 2x minus 9 equals negative 11. This one gives me 2x equals 20 or x equals 10. So I know 10 is one of my answers. So, well, maybe it works, maybe it doesn't. Subtract this, I get 2x equals negative 2, x equals negative 1. So it's either negative 1 and 10 or just 10 or just negative 1. Actually, it can't just be negative 1. So I know this isn't the answer. If I plug in 10, that would give me 20 minus 9, which is 11, and that would give me negative 11. So that works. If I plug in negative 1, this gives me 2 times negative 1. That's negative 2 minus 9 is negative 11. The absolute value of negative 11 is positive 11 with a negative out front. It looks like they both work. So this is my answer right here, choice 4. They both work. And again, this is another one you could have just stowed and plugged them in and go. All right, that's it. Come back for the next half in just a few minutes.